going to do a quick little tutorial on slope and rate of change, graphing linear relations. Had a question about this, so let me just make up a new old equation. Let's go with y equals 2x plus 1. And we can graph this a couple of ways. First way we're going to do it is table of values. I'm going to make a quick table here. I can do better than that. I can actually select the table from here. Okay, so we can pick anything we want for the x's. I usually pick, maybe one or two negatives, so -2, -1, 0, 1, 2, 3. And now we're going to plug into the actual equation. So 2. So for the first one, we would go y equals 2 times -2 and then add 1. So I'm going to get y equals -4 plus 1, y equals -3. Okay, so that out of the way. I'm going to keep my -3. Okay, similarly, we can plug in -1. 2 times -1 would give me a -2, plus 1 would be -1. Continuing down the table, 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus 1 is 3, and then we get 5. Okay. Something we looked at a little bit before was the first differences. And first differences, I know some people had some confusion with that. They were actually looking at the difference between the y and the x. It's the first difference in the y values. So we just subtract these. Now, really what we should be doing is subtracting the second minus the first, third minus the second, and so on. So I'm going to show you the first one. -1 minus -3 really turns out to be -1 plus 3. So we end up getting 2. Next time, 1 minus -1, again, is 2. 3 minus 1, 2. 5 minus 3, 2. 7 minus 5 is 2. So these first differences actually represent, that's the rate of change, okay? And it turns out it's the same as our slope value. Remember, y equals mx plus b? So the slope is the same as first differences, and it's also the same as our rate of change, okay? So to graph something like this, we could plot the table of values, but let's look at it a different way. So I'm just going to snip this to the new page. Insert a graph. This one's actually almost a little bit tougher when the slope turns out to be 2. It's almost better when it's a fraction, believe it or not. So my y-intercept in this case is the b value, which is 1. So that's where I'm going to start from. So I put a dot on the y equals 1. The second part is my slope, which is my m value, is equal to 2. Now, you might remember that as being rise over run, so you might want to write 2 as 2 over 1, which is rise over. So what we're going to do from this point is we're going to actually go up 2, and then over 1. So there's my next point. And again, up 2, over 1. And then we can go ahead and draw on our line. Now, when we draw on the line, oops, I draw on the line. I don't want to just stop here. I kind of continue all the way down. Okay. And if you look at the points, some of the points that we actually have, some of the points, they would match up. So one of the points we should have had on our table was -1, -1, or -2, -3, if you remember back to the table from the previous page. Okay. So the other thing we would sometimes want to do is come up with what the equation is. Okay, so from a given graph. So we can maybe do that on the next page. So maybe let's try graphing one more before we move along too far. Okay, let me just make up one. Let's say we had one 3y minus 2x. Let's go with, I don't know, -9 equals 0. Okay, so what we have to do first in this case is put it in the form y equals mx plus b. Let's try that. We're going to go 3y. Moving these guys over, really what we're doing is we're adding 2x to this side and adding 9 to this side, so we get 3y equals 2x plus 9. Now that's almost in the form y equals mx plus b, but we still have a 3 up in front. So we need to divide by 3, and divide by 3. we end up getting y equals 2/3 x.
Sorry for the interruption. Mike Conway, would you call 4643, please? Mike Conway, 4643, please.
Sorry about that. Okay, so we have our y equals mx plus b form again. So we can clearly see that the slope, or my m, is 2/3, which is slope, and my b value is 3. Remember, slope again is rise over run. Okay, so if I actually made a table of values for this thing, you would notice that the y values are increasing by 2/3 each time. So let's go ahead and try to graph this one. So again, my starting value is 3. Then my rise is 2, my run is 3. Maybe I wish this would have turned out to almost be a -2. And instead of, so with a -2, instead of going up 2, we would have actually gone down 2 and then over 3. Okay? But we'll stick with our positive. So just in case that comes up later on, if you have a negative, you're going to go down instead of up initially. So up 2 over 1, 2, 3. Okay? And you can extend it back as well. So then there's our line again. So hopefully that's okay. Let's try maybe coming up with the equation of a line as well, okay, before I stop the video. Okay, so I'll make any line actually. Okay, so hopefully that looks pretty good. Okay, so to find the equation, first thing that we can kind of see here is the y-intercept. So we know we have to get in the form y equals mx plus b. So the two things I'm required to find here are the m, which is slope, and b, which is y-intercept. So my b, which equals y-intercept, is equal to 2. Okay, that's pretty easy to pick off the graph. Okay. Next one is the slope. M equals slope. Remember, slope is equal to rise over run. Now, sometimes you're not given the graph and you actually have to use y2 minus y1 over x2 minus x1. So that's if you're actually picking a couple of different points. Okay. So I don't know. I'm going to pick one here. This one looks pretty nice. There's another pretty nice one. Okay, so I'm going to just draw a little triangle here. Okay, that's off. And so the rise here, going from this point to this point, my rise, you should see, is actually -2. I'm going down 1, 2 squares. And my run is 1, 2, 3, 4. Right? So it's positive. So my slope equals -2 over 4, which is -1/2. So my final equation that just becomes just plugging in, therefore y equals -1/2 x plus 2. Okay, so hopefully that helps. The only other thing that I'm wondering when you ask the question about linear relations and rate of change, could be if you're given a couple of points. Let me just make up one. Let's say we have the point 1, 2, and at the second point 3, 7. Actually, make it 3, 8. So if you ask for the rate of change here, the slope, not so easy to do rise and run in this case. What we do is we subtract the y's. Sometimes they use delta y over delta x, just meaning difference in y over difference in x. So as long as you're consistent here, I don't care if you go 8 minus 2 or 2 minus 8. However, if you go 8 minus 2 the first time, we must go 3 minus 1 the second time. So I get 6 over 2. Slope of 3. So that's the reason I changed my value here. It would have turned out to be a fraction, which isn't that big of a deal. Okay. So now we have y equals mx plus b, so it's going to be 3x plus b. However, I don't have my b value. To find the b value, we can plug in either the 1, 2 or the 3, 8 and solve it for b to find out what that would be. So we're going to sum in the point. I don't know if one's nicer than the other. Maybe the first one will go with smaller numbers. 1, 2. and then I get 2 equals 3 times 1 plus b. Solving equations again, I get 2 equals 3 plus b. Move the 3 over, subtract 3 from both sides, we get 2 minus 3 equals b, and b equals -1. Therefore, y equals, again, my m was 3, x, and it's going to be -1. Nice thing about this is you can check your answer. So we had the 2 points, 1, 2, and 3, 8. You can plug 3 into here. So 3 times 3 would be 9, minus 1, sure enough, is our 8. Okay, so if you have any other questions, please feel free to ask.